Hello everybody, this is Rudra Pradhan here and welcome to BMD lecture series. Today we will again continue the content called as a inferential analytics, and in the last couple of lectures we have discussed this concept regarding the inference analytics. So, here the idea is two types. So, we have to comment on population with respect to sample information, and then in the second instance with the help of sample informations we have to create a confidence interval for the population parameters. So, we have a couple of lectures discuss means couple of lectures we have actually discussed to know how to validate the population parameter by using the sample statistics, and again we have also discussed using sample statistic how we have to create a confidence interval for the population parameter. And in this lectures we again try to find out confidence interval for the population parameter, and that too by using different test statistic, that is the variance test statistics. And so far as a variance test statistic is concerned, we have a two different distributions. One distribution is called as a chi-square distribution, and then we have a F distributions, but today's discussion is on chi-square distribution, and that too using chi-square distributions we like to know how confidence interval can be built for population parameters, right. So, since it is a variance indications, so the population variance need to be predicted here, and that too population variance confidence intervals we have to find out. And there are two parameters, population parameters mu and standard deviations, that is the variance. And in the last lectures we have discussed the confidence interval about the population mean subject to using Z statistic and T statistics, and then here we have to create confidence interval for population standard deviations and by using a chi-square distributions. So, the game is like this, and let us first give some kind of hint about the variance. So, in any kind of empirical testing procedures, so two standard indicators are mean and variance, and we have already discussed so many problems by using the mean of the particular structures and variance of this particular structure. So, now some of the test statistic and some of the kind of problems can be actually investigated by the mean statistics, and some of the problems can be again predicted through the variance of this particular series. So, now here the idea is that how variance can be used or can be it can be helpful for predicting the problems and to get some kind of inference about the population parameter. First of all, we should know what is exactly the variance, that is the population variance. Variance is an inverse measure of the group's homogeneity. Variance is an important indicator of total quantity in standardized products and services. Sometimes it will give you some kind of indication about the consistency of a particular series. So, if the variance of a particular series is very high, then that series is very can be considered as a volatile and inconsistent, where compared to a series where variance is very less. So, we try to actually predict the situations and try to minimize the variance, so that the accuracy or uncertainty factors can be minimized as per our problem is concerned. And it is sometimes in finance it is actually very good measure to predict the risk component, and variance of any kind of assets will predict the kind of situation whether the kind of asset is consistent behaviors or inconsistent behavior. So, the market prediction completely depends upon the variance indicators. So, the typical structure or decision making is like that when the variance factor will be very high, then the prediction would be not so good actually. But in the case of variance less, so where the prediction can be slightly perfect. So, in any situations, so we like to find out what is the volatility of this particular series or variance of this particular series. So, that we may be in a position to predict as per the problem requirement. So, now after knowing all these things so you like to know what is exactly the concept and how we can use for this particular confidence interval structure. So, far as a population is concerned, so there are two parameters which I have already mentioned, sigma square and mu, and in this particular case we are actually targeting the population parameter sigma square. And first of all, you should know how we have to calculate the variance, which we have already discussed, and that too. So, this is actually for any kind of sample. So, your variance of a particular series can be calculated like this, and the square root of this variance by default is called as actually standard deviation. And for a chi-square formula for single variance will be calculated like this, and in fact, actually some of the software by default will give you these values of the chi-squares, and then that will be helpful for some kind of prediction and some kind of comments about the population parameter. So, now so here the standard structure is that so first you calculate the S squares, that is the estimator of sigma square, and then with the help of S squares, so you have to calculate the chi square. So, that is the with respect to sample adjustment and the population parameter. So, this is actually population parameter and this is what actually sample variance, right. So, on the basis of that, so we have to calculate the chi squares, and that too with the help of degree of freedom n minus k. So, now corresponding to this, so you have to see how is this particular confidence interval structure. So, now you see previous. So, what is our objective, that using chi-square value. So, we have to create a confidence interval for these sigma squares. So, that means, in the earlier case, so having S square information, sigma square informations, we are calculating chi-square value, and then chi-square statistic will give you some kind of prediction or some kind of comments about the null hypothesis and alternative hypothesis. But here the structure is just opposite. So, now having the chi-square value and the sample informations, we like to create a confidence interval for the population parameters. Like the previous lectures, we have actually given a kind of confidence interval for population parameter mu by using sample information and the kind of test statistic like Z and T. So, here having the same information since we are targeting the variance of this particular population. So, chi-square is the right choice to use for this particular prediction. So, far as confidence interval of population variance is concerned. So, that means this particular formula, like same thing earlier we have discussed. First you calculate the Z statistic, calculate the T statistic, then having the sample mean you have to create a confidence interval. So, here the same things. So, having the chi-square structure, and then you have to create a confidence interval for the population variance. So, that means, here the idea is actually, so the population variance needs to be actually predicted. So, the targeted element in this particular structure is to create a confidence interval for sigma squares. So, like we have already discussed the confidence interval for mu in the earlier case by using T and Z. So, here the idea is to create a confidence interval for Z square subject to availability of chi-square information, sample information and the sample variance. So, that is how the kind of structure altogether. So, let us see how we can do this. Okay. Okay. So, this is what the kind of so this is what population variance, and now this is actually sample variance, and this is chi-square statistics, and this is the sample adjustment factor, that is nothing but called as degree of freedom. So, that means technically to get chi-square value, so we need actually alpha and degree of freedom, right. So, alpha is the type 1 error. So, that is actually probability of significance and the rejected zones. Then by putting the both the sides options. So, we like to create a confidence interval. So, that means we like to know what is the chi-square value at a particular point of time by fixing alpha and the degree of freedom. So, from the particular problems, so you can easily get the degree of freedom, which is nothing but actually n minus 1 for one sample case, and alpha is in your controls. You have to fix a kind of structure through which you need actually confidence interval. You can put alpha 1%, you can put 5%, you can put 10%. So, it can varies actually. So, now having variation of alpha and having the degree of freedom, you can get chi-square value. Once you get the chi-square value, so then for since it is a kind of confidence interval, lower bound and upper bound. So, by default you will allow alpha to go in both these sides. So, as a result, the choice will go alpha by 2 in the left side and alpha by 2 in the right side. Then remaining 1 minus alpha, 50% will be in the left zone and 50% will be a right zone, and that is what the confidence interval, and that too for population variance sigma squares. So, now so first you have to actually the first and starting point is to fix alpha, that is what actually the kind of confidence interval. So, 1 minus level of confidence interval is nothing but actually alpha. So, obviously, so confidence interval is nothing but called as 1 minus alpha. So, first you fix the alpha and then by default you will create a confidence intervals, right. So, this is how the typical structure, this is the lower bound structure and this is what the upper bound structures, right. So, now knowing the s square value and the chi-square value, you may be in a position to know what is the lower range and what is the upper range for the population variance sigma square. So, let us take an example. So, how it will actually work. Let us first understand the chi-square tables, then on the basis of chi-square values. So, you may be in a position to create a confidence interval for the population parameter. So, now in usual chi-square table will be like this, and here in the first first column you will find ranges of degree of freedom starting with 1, 2, 3 and so on. So, now corresponding to a particular sample structure. So, you can get to know degree of freedom. So, degree of freedom depends upon two things. So, your sample observations n and the variables involvement is k. So, since we are actually discussing one sample case, so every time k will be 1 for one sample case and the sample size is n. So, obviously, degree of freedom is usually for one sample case is nothing but called as n minus 1. So, now if your n is equal to say 10, then by default degree of freedom will be 9. If your n equal to say 20, degree of freedom will be 19. If n equal to say 25, then degree of freedom is 24. So, like this degree of freedom can be calculated, and then you want to specify or you have to specify the kind of confidence intervals. So, if you do not fix the kind of alpha, then you may not in a position to find out the chi-square value. So, one requirement of chi-square figure is the degree of freedom. So, this is very easy to find out depending upon the number of variables involvement and the sample size, and then for confidence interval requirement. So, it depends upon alpha fixation. So, if you put alpha equal to say 10%, then obviously, corresponding to 10%. So, this is actually coming as actually the chi-square value. So, it is coming 9.236. So, this is what actually the chi-square test statistics corresponding to degree of freedom. In this case, degree of freedom is coming 5. So, that means sample size is n, and then alpha is actually 10%. So, as a result, your chi-square is coming 9.23635, right. So, now we need actually confidence interval for sigma squares and subject to use of chi-squares. So, now first of all you need to specify the chi-square requirement and then get the chi-square critical, the chi-square test statistics. Then using the chi-square test statistic you can create a kind of confidence intervals. So, now actually we need actually confidence interval. So, the lower bound and upper bound, but this particular distribution is actually positively skewed distribution. So, as a result, so the particular structure will be in the only one particular domains, and accordingly, so you have to fix a kind of confidence interval. So, that it will be positively skewed, and then it will follow as per the particular requirement, right. Let us see here. So, the kind of structure, and in the next slides I will give you the kind of structure about the confidence intervals. So, let us start with the fixing of the ranges of the lower limit and upper limit. Now, for confidence intervals you need actually two values, and one value will be these ones, and the the upper value will be these ones, right. So, that means actually corresponding to a degree of freedom. So, you will find the particular. So, if you are fixing actually 5% here, then the 95% of area will be covering like this. Okay. So, as a result, so the 95% of area coverage and corresponding to the degree of freedom, the critical value will be coming actually 2.167, that is actually 5% range. Then the upper value will be actually 14.07. So, that means actually we need a lower bound and we need actually upper bound, and that too to fix the confidence interval for sigma square. So, now in the lower bound, so the chi-square value reporting will be this much, and the upper bound the chi-square value reporting will be 14.07, and that too at the 5% probability levels. So, now corresponding to these two figures, so let me let us see how this particular confidence intervals, right. So, now okay, see here, let us take a standard example, since in the previous slides we have actually fixed at a kind of 95% of confidence intervals. So, now in this examples we are putting 90% of confidence interval for actually population variance sigma square. So, that means we like to know what is the confidence interval for sigma squares when we are fixing 90% of confidence interval, and that too sample size of n equal to 8, and and sample variance is nothing but actually 0.002. So, as a result, so that means actually the standard requirement of this confidence interval, first actually the sample statistic, this that is the sample variance, and then your this sample size reporting, and as a result you can find out the degree of freedoms, and then you fix the confidence interval. So, since we are allowing both these sides, then chi-square alpha by 2 is nothing but actually upper side is coming actually 14.07, and then in the other sides it is coming actually 2.16735. So, that means that is what actually the difference between these two. So, chi-square 0.95 and chi-square actually 0.05. So, the lower range and the kind of upper range. So, corresponding to the lower range, so this is what actually the kind of critical value, and this is what the kind of critical value where 95% is concerned. So, as a result, so we have to fix the lower bound corresponding to this particular 0.05, and then corresponding to 95%. So, you have to find out the kind of upper bound, right. So, as a result, so the sigma square will be now putting all these values like degree of freedom here 8 minus 1, then the sample variance and the chi-square value alpha by 2 for 5% is coming actually 14.07. So, after putting all these things, so this will give you the kind of value called as 0.001. So, this is the lower value or lower confidence interval for sigma square, and again chi-square 95%, the upper value is coming 2.17. So, now again with the adjusting degree of freedom and the sample variance, so you will find the upper range. So, the upper range is coming actually here 0.007. So, that means having actually a sigma SS the sample variance 0.0002. So, your lower bound population variance will be 0.001 and the upper bound will be 0.007. So, this is how this is upper bound, and this is how the kind of prediction about the confidence interval, so subject to availability of sample variance. So, that means here there are two different structure altogether for confidence interval, and one particular structure is to find out population mean and then create a confidence interval, and for that you can use Z statistics, you can use T statistics, and that too with having information about the population standard deviations and without information of the population standard deviations. And in the case of population variance confidence intervals, so we are supposed to use actually chi-square distributions, and then with the help of the kind of sample size and the alpha choice, we can create a confidence interval for sigma square. So, that means technically it is altogether actually the kind of predictions or inference about the population parameters, that is nothing but actually mu and standard deviations, and that is variance, mean mu and variance standard deviations. So, now but the choice of test statistic will be different as per the particular structure and the kind of requirement. So, so far as mean confidence interval is concerned, that is population mean confidence interval is concerned. So, either Z statistic can be applied or T statistic can be applied depending upon the large samples, depending upon the small samples, and the kind of sigma availability and sigma sigma known and sigma unknown situations. But in the case of population variance confidence intervals, so the standard choice will be always actually chi-square chi-square test statistics. So, having chi-square informations, you can create a kind of confidence interval, and that is what the kind of structure which we have already highlighted. And in this case, so the standard structure requirement is to find out sample variance first and report the sample size and report the confidence interval, that is the alpha value, and on the basis of alpha value you can create a confidence interval for the sample variance, means population variance, but it will be with the help of only sample variance. Without knowing the sample variance, you are not in a position to create a confidence interval for population variance. So, that means the entire inferential analytics, we have actually two different work plans altogether. In one case, so having sample information, you are committing to the population parameters, and whether it is with respect to mean or variance, but in other case having sample statistics, you can predict the kind of structure about the population statistic, that is actually population mean mu and population variance sigma squares. So, both the cases actually kind of consist what we call as very kind of complementary, and once you know a particular situation, you can actually predict the other situations, and vice versa is also equally true. So, now corresponding to these particular structures, so we will see here. So, the kind of solutions. So, there is another kind of example here. So, this is again sample statistic sample variance, that is actually 1.254, and then degree of freedom is actually 24 corresponding to the sample size 25, and then again alpha you can fix actually 5%, that is 0.05. So, then again you have to find out chi-square the lower bound and chi-square the upper bound. So, the chi-square lower bound will be this ones and the chi-square upper bound will be this ones, right. So, this will be actually the kind of requirement. So, once you get the kind of sample variance, then using the sample variance, so you have to see what is the confidence interval for the population variance. So, that means technically having a sample variance 1.254. So, what is actually the upper limit, sorry, lower limit, and lower limit and upper limit for this particular problem. So, again the same structure. So, using sample variance, so chi-square lower limit and chi-square upper limit, and that too with the help of alpha and degree of freedom. So, you can just report these figures, then automatically you can simplify, and you may be in a position to get, predict what should be the population variance lower limit and population variance the upper limit. So, that is actually standard structure through which you can actually frequently know this issues, and then predict the problem or predict the environment as per the particular requirement. Okay. And this is what actually the standard jet structures, and usually the standard normal normal distributions is structure is like this, z equal to x bar minus mu. So, that means see here. So, this is actually sample statistics, and this is what the population parameters. Every times we like to means one of the objective in this particular inferential analytics is to find out the difference between sample statistics to population statistics. So, that means in the first instance you like to check whether sample mean is converging to the population mean, and if sample mean is converging population means, that means it is completely unbiased kind of things, and this is very efficient and very effective. And if that is the case, and your sample selection will be very appropriate for this particular problem, or the kind of decision making is concerned. If the sample mean is not converging population means, so then there is a difference. So, the difference is nothing but called as bias. In this case it is called as error of estimations. So, now we need that this bias should be equal to 0. So, one way to make this equal to 0 means if your samples identification or sample selection will be very perfect as per the problem requirement, or else you sometimes you can increase the sample size, then the biasness will be by default will be reduced slightly, and every time our approach reduce the bias and make the system unbiased. So, that means sample statistics should be converged to population statistic. If not, then then the prediction rules or the kind of prediction environment will be not so effective. So, it may give some kind of wrong decision kind of thing. So, that is how every time we try to find out how to bring less and less bias in the system. And now here one of the interesting thing is that in the process of this inferential analytics. So, the first two cases which we have discussed actually to comment about the population parameter subject to sample statistics, and again second issue is to predict the population parameters and subject to samples statistics information. That is what actually the prediction about the population parameter mu and population parameter sigma square, and that is what actually the confidence interval. So, now another things which we can actually explore in the inferential analytics is nothing but actually the kind of what we called the sample size. So, now since this is actually well structured. So, having the information about test statistic and the parameters value. So, sample size can be also actually estimated here. So, that means actually in one case. So, you are targeting the population parameter subject to sample statistic, then targeting sample statistic which is population parameter subject to information about the alpha and degree of freedom or sample size, and now in the same process having all these informations, you may be in a position to exactly specify what should be the estimated sample size. So, now by this formula it is very easily you can actually detect the kind of estimated sample size. So, that means in the empirical investigation process, so it is very difficult to say whether the sample is very accurate or very efficient. So, that is why we need to specify what should be the optimum sample size, so that the prediction can be very perfect as for the kind of problem is concerned, right. So, in the overall actually empirical process, research investigation says that estimated standard deviations should be equal to 1 by 4 range. Range is nothing but actually the difference between a lower limit and the upper limit. So, like that I will give you some kind of examples through which actually you can actually predict the kind of sample size in a kind of given situations. Like in earlier case having sample information, having sample size and the sample statistics and the confidence intervals, you can predict the population parameters. So, here also same things, having some kind of information about population population information and sample information, then you can check the kind of biasness, and with the help of biasness you can able to detect the size of the samples. So, it is as per the previous discussion. So, this to for using Z statistics, you can actually in a position to report what should be the sample size. For instance, so this is nothing but actually x minus mu. So, that is the bias created in this particular investigation process, and having sigma equal to 4 and 90% confidence intervals, then Z is coming 1.645, and then accordingly n will be by default just putting actually Z value here, and sigma square 4, and then the biasness. So, you can able to predict what should be the actually sample size. So, that is what actually 44. So, that means actually the thing is that the problems are very complementary kind of things. If you know certain things, then you are in a position to predict other things as per your problem requirement. So, whether you are commenting the population parameter or predicting the population parameter, or you are targeting the size of the samples. So, whatever the requirement. So, the system or an inferential analytics will help you lot to generate all such informations as per your problem requirement and the kind of management decision is concerned. Like, so, I will give you another examples, and which can give you the snapshot about the sample selections. Against, let us say E equal to x minus mu, that is the bias equal to 2 and the range that is 25, and the 95% confidence interval, the Z value will be 1.96. So, now, so here actually the sample range will be the Z square and standard deviations, using the standard deviations, which is nothing but actually 6.25, and sample size will be coming actually 38. So, that means having all kind of informations, biasness and population variance and the Z statistics. So, you are in a position to calculate the sample size. Sometimes why it is actually required to discuss, because sometimes the structure is so complicated and you may not be in a position to know what is exactly a population size, right. So, population may be actually finite type and infinite type, but exactly what should be the kind of size, it will be very easily actually predicted through this particular structure, since it all are correlated, and it is very easy to predict the kind of requirement as per your objective and the kind of problem requirement is concerned. Okay. So, likewise actually it can be also useful for sample proportions. So, like we have discussed x bar minus mu. So, here actually sample proportion, this is actually sample proportion and this is population proportion, and with the help of sample proportion and population proportion. So, you can also in a position to calculate the size of the sample. So, like this so this is actually, so means this test means what I like to say that the test statistics are very useful component to predict certain things as per the kind of problem requirement, right. So, once you know a particular test statistic structures, So, having the sample information, so you can predict the population information. So, having sample information and population structures, you can increase the kind of sample size. So, now this is another way to having the kind of bias calculations. So, same way you have to report the sample size, right. Only thing is here actually the kind of biasness is is the difference between sample proportion minus population proportions, and then with the help of the kind of standard errors and the kind of z value. So, you are in a position to report the sample size, right. So, the estimated sample size for this particular case will be like like to be reported by this particular formula. Okay. So, let us take an examples and then we will highlight how is it actually the case. Okay. So, so let us say bias is coming 0.03 and we are fixing 98% confidence interval, and for that intervals z is actually 2.33 and p is actually 0.40, and by default q equal to 1 minus p, and that is coming actually 0.60. And now, so having z figures and having e figures and having the p q figures. So, very easily you can predict the actually estimated sample. So, that in this case the sample size will be 1448, right. So, this is means this is a typically actually very interesting kind of inference we can draw with the help of all these test statistics, z statistic, t statistics and chi-square test statistic. Okay. So, this is very standard kind of structure through which actually you have to predict the environment. So, now likewise the p can be varying subject to kind of variation, and this is a kind of classic kind of structure. So, means it gives actually the kind of snapshot that when actually p is changing one domain to another domain. So, the size of the sample is also actually changing. So, that means actually this graph says that at a particular point of time you can conclude that every time it is not that increasing sample size will give you actually a very consistent results or very effective results, but it is not the increased samples, it is the concept called as optimum samples always give the better decision and fair decisions, because sometimes for example, let us say you are going for for stock market predictions, but having stock market predictions let us say 10 years data or 5 years data, it is very reliable to do the kind of predictions, but having 50 years or 100 year data, then today's stock market prediction may not be so effective. So, so accordingly, so it is clear cut signal that it is not the increased sample size always give you better accuracy or better kind of management as per the requirement. It is the optimum size of the sample will give you better kind of inference, and it will give you better management decision. So, that is why you must know what should be the kind of optimum sample for a particular problem. It some problems having more samples may give some kind of more biasness, or having less samples it will again give more and more bias to the systems, and when your bias is very high in the system in the process of investigation, then by default it will give you some kind of means it will give you some kind of negative kind of clue to give a better kind of prediction or to give some kind of better management decision. So, that is why at a particular point of time you should know what should be the optimum sample structure so far as problem investigation is concerned, and this is how the the kind of structure this figure typically highlights that it is not the increased sample size, it is the optimum sample size will give you the appropriate decisions or so far as management requirement is concerned. Okay. So, like this is another example through which actually again you can increase the sample size, and keeping 90% of confidence interval and biasness 0.05 with p value 0.50, you can able to calculate again sample size, and in this problem the sample size is again coming actually 271. So, that means there are plenty of examples you can cite here. So far as sample information means it is a prediction about the sample size. So, that means three things we are here doing in this particular inferential analytics, that to part 1. And here actually using sample informations you are giving comment to the population parameters or population statistics, and again using sample informations you are creating a confidence interval about the population parameters. Again using actually sample information and the kind of population informations, you are in a position to predicting the kind of sample size, and all these are highly relevant so far as particular problem is concerned and the management decision is concerned. So, that means altogether we are having actually three ways of a kind of getting inference for a particular problem. So, it will give you better exposure, better kind of kind of setups through which your prediction can be perfect, and you may be in a position to get better inference to solve the problem and to take some kind of management decisions, and that too as per the problem requirement. So, likewise these are the things we are supposed to discuss in the case of inferential analytics. And so far we have already discussed the kind of concept about the statistical inference, hypothesis testing, the kind of requirement, the kind of structuring, various test statistics, the requirement of test statistics, the kind of structure of test statistics, the objectives behind the test statistics, and the kind of problem requirement. And in whatever we have discussed in this particular unit, it is related to one sample case only. But by the way, in real life situations so many problems will be there which is actually multivariate in nature. So, that means we will find in many instances, so there will be a kind of problem which can be connected with multiple samples. That means it is a multiple variables involvement, and in that case same test statistic can be applied to predict the kind of situation and to do some kind of means to look for some kind of management decisions. But the procedure and the kind of structuring is slightly different. It is more or less same, but like one sample case, but in the case of multiple sample case some more test statistic can be applied, but same statistic with a kind of different structure. For instance, we have not discussed in this unit called one particular distribution is called as F distribution, which is actually multivariate kind of concept, and we will discuss in details in the next unit. But by the way, so when you have actually one sample case or one variable case problem, then whatever we have discussed in this inferential analytics in this particular unit. So, I hope you will get enough exposures to predict the kind of business requirement and the kind of you may be in a position to take some kind of good management decision. Now, in the next unit we will discuss details when there is a multivariate case, how you will go for some kind of prediction, that is what is the game plan for sampling to population, how to predict the population again with respect to creating a confidence interval, again how to predict the sample size, all these things. So, we will discuss in details in the next lectures, and that too in next unit, that is unit 5. With this we will stop here. Thank you very much. Have a nice day.